Hi dear everyone. Online MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject analog devices and circuit, unit number 2, chapter 2. Okay, last chapter we discussed about the what is op-amp, what are the ideal characteristics and uh, what is differential amplifier and its type, like that we discussed. So in this chapter we are going to discuss about the AC and DC characteristics. That means in operational amplifier in practical condition, if you're giving AC input means what is the characteristics will be varying. So sorry, what are the characteristics will be varying, as well as if you're giving DC component means what will happen in the output side or what will happen, uh, what is the change to the operational amplifier, like that we are going to discuss in this chapter. That is generally we have a DC characteristics like input bias current, input offset current, input offset voltage, thermal drift. So like that we have AC characteristics, sleeve rate and frequency response. So first one DC characteristics. So let's see the thermal drift. That is the output voltage changes with respect to the temperature. Okay, that is rate of change of output temperature with respect to the rate of change of output to voltage with respect to the rate of change of temperature. So அதான் நம்ம வந்து என்ன சொல்லுவோம், thermal drift அப்படின்னு சொல்லுவோம். So mostly it will be not affect the ideal condition, but it will used in the most of the circuit, because நம்ம power supply க்கு பதிலா ஒரு temperature கொடுக்குறோம் அப்படினாலே அது power supply என்ன ஆகும், it will be a some variations will be there. Okay, so let's see the different thermal drift. That is first one is input offset voltage drift. That is defined as the average rate of change of input offset voltage per unit change in the temperature. It is also called as input offset voltage drift. That is தெரியும். That is del VIYS divided by del T. Okay. So it is expressed as the microvolt change of with respect to the single degree. Okay, input bias current drift. So thermal drift, it is defined as the average rate of change of input bias current per unit change in the temperature. The thermal drift in input bias current is equal to del IB divided by del T. Okay. Input offset current drift. So it is defined as the average rate of change of input offset current per unit in the temperature. Okay. So what is the change of input offset current drift with respect to the temperature variations? So it is defined as the nano ampere or picoampere. So that is slope can be either polarities or like that. So next one, some AC characteristics of the op-amp. So when we are giving the DC power supply like that, current voltage means it will happen different trips concept. Same as in AC characteristics, we have frequency. That means if we are giving low frequency, if we are giving high frequency like that, what it will, the characteristics of the op-amp will be changed like that. We are going to discuss in this concept. Okay, the variations of the magnitude and phase angle of the gain due to the change in the frequency is called frequency response of the op-amp. Okay, the manner which the gain of the op-amp changes with the variation in frequency is known as the magnitude plot. The manner in which the phase shift changes with the variations in frequency is known as the phase angle plot. So this is the frequency response equation. How it is obtained? To obtain the frequency response, so consider the high frequency model of the op-amp with the capacitor C at the output. So taking into the account the capacitive effect present, that is AOL of F is equal to AOL divided by 1 plus j of 2 pi f r0 c. That is AOL of f is equal to AOL divided by 1 plus j of f divided by f naught. That is f naught is the break frequency or cutoff frequency of the app-on. That is f will be the operating frequency. AOL is the gain of the operational amplifier. So this is the magnitude equation and phase angle equation. So magnitude equation AOL of f is equal to AOL divided by root of 1 plus f divided by f naught square, as well as the phase angle, that is tan inverse of f divided by f naught. So this is the different variations of frequency. If you are giving 0 means what will happen? The phase angle will be 0 degree. If it is we are giving 1000 means the phase angle will be changed to the up to 89.71. Okay, this is the table for the frequency variations. Okay, so the modes of operation amplifier. So there are two modes. One is open loop mode and one other one is closed loop mode. That is open loop mode means we are giving some input, there will be output. Okay, என்ன பண்றேன் input கொடுக்குறேன், some output வருது, switch போடுற fan ஓடுது. Okay, that is the basic model. So that is open loop condition. We can control the output through the input only. Okay, so but in the closed loop condition we are taking some part of the output to the input. So that means we are connecting the some resistance between the input and the output. It will define the gain of the output. So we can vary the by varying the resistance value we can define the output. Okay, this is the concept of closed loop. Most of the application they are using the closed loop condition. In open loop configuration there are three configuration: differential amplifier, inverting amplifier, non-inverting amplifier. So that is differential amplifier V out is equal to AOL of VD is equal to AOL V1 minus V2. Inverting amplifier, the amplifier in which the output is inverted. So that means if we are giving input sine wave means the output will be 180-degree phase shift. Okay, so same as non-inverting amplifier, there is no phase shift, but it will be amplified. So that is the amplifier in which the output is amplified without any phase shift in between the input and output, called non-inverting amplifier. That is VO is equal to AOL into P. Yeah. Why op-amp is generally not used in the open loop mode? So that is we have to define. Okay, so for example, in open loop condition we have high gain, but there is no control of gain. That means we cannot vary the gain output. Okay, that means some standard output, standard input like that will be we have. Okay, so for this purpose only we have operational amplifier open loop condition will be not be used in the many applications. Okay, so that is a simple concept is we can vary the more number of gain levels. So only we are define the closed loop. We prefer the closed loops concept for the different applications. So this indicates the inability of op-amp to work as a linear small signal amplifier in the open loop mode. Hence the op-amp in the open loop condition configuration is not used for the linear applications. Okay, that is linear and non-linear application. For open loop condition, you will get only the output of a square wave like that only. But in a closed loop condition, you can get the sine wave. That is varies with respect to the time namakandi, we can get the output. But in the open loop condition, you will get 0 or 1. Like that you will get. Okay, this is the basic characteristics of the operational amplifier, that is AC and DC, as well as we discussed what are the different configuration, that is open loop and closed loop configuration will be defined. Okay, thank you. So next class we will see the applications of operational amplifier.